Lesson 6.3 is all about solving quadratic equations by factoring. Say what? Yes, factoring. The concepts that we learned in our previous chapters, in this case, previous chapter was chapter 5, talking about factoring, will come back to help us in these upcoming chapters. So TGFF. Thank God for factoring, because that will be a really good help here in these cases. So remember from 6.2, anytime that we are solving quadratics, we always want to get them into the form of an equation set equal to 0. So the first thing that we're going to do as we solve each equation here is set them to 0. So in our first example here, x squared equals negative 4x, we want to set that to 0. So what I'm going to do is just add 4x to both sides, in which case we now have x squared plus 4x equals 0. So now we have a much more workable equation. First thing we want to recognize here is we have an x term in each of them that we can factor out. So if we just take an x right out of each of these, we're left with x plus 4 on the inside equals 0. Now in this case, we have essentially two numbers we're looking at. We have the monomial x on the outside here, and we have the binomial x plus 4. Now, both of them are being multiplied together to get 0. So essentially we have one number, we'll say n, times another number, maybe m, multiplied to equal 0. So anytime we have two numbers multiplied by each other to equal 0, one or the other has to be 0. Either n equals 0 or m has to equal 0. One or the other has to happen. So, looking at our example here, either this side, the x has to equal 0. That way we'd have 0 times 0 plus 4 would be 4. 0 times 4 is 0. So that would work. If we are just looking at this part of it, we want our x to be negative 4, because negative 4 plus 4 would be 0. That way, our outside x would be negative 4 times negative 4 plus 4 is 0, and negative 4 times 0 is 0. So that would be true. So we can either have x being 0 or x is negative 4. These are our two solutions. Now moving on to our second example here. We have 3x squared equals 5x plus 2. Again, we want to get it into a form where it's set equal to 0, so I'm going to subtract 5x and subtract 2 from both sides. This way, we can get it into 3x squared minus 5x minus 2 equals 0. Now once we have it in this form, we're going to need to use another method of factoring. Now before we called it the AC method, and it was a little bit longer, I'm going to show you a simplified version of the AC method. It starts out the same, where we take a and c, 3 times negative 2, and we get negative 6. And we're looking for the factors of negative 6 that will add to negative 5. In this case, it's going to be negative 6 and positive 1. Now that we have negative 6 and positive 1, we just set those back into our equation in place of the negative 5x. So we'd say 3x squared minus 6x plus 1x. So when we combine these, they become that 5x minus 2 equals 0. Once we have it in this form, we can factor by grouping. So we group this and we group this. In our first part here, 3x squared minus 6x, we can take out 3x from both pieces, which is going to leave us with x minus 2. In our second part, there's nothing left for us to factor out. So we'd say that it's 1 times the amount x minus 2. And it's still all set equal to 0. From here, after we've done our factor by grouping, we notice we have our x minus 2 in both spots. So we'd say x minus 2. In one case, it's being multiplied by 3x. And in one case, it's being multiplied by 1. So these are our factors. And again, they're still set equal to 0. Now that we have it in our forms where we have each factor, and together they're set equal to 0, remember, we need this one to equal 0 in one case. So we would have x equals, the way to make this one 0 is our x has to be 2, because then 2 minus 2 is 0. That way we have one side being 0 times whatever number this comes out to be. 0 times 0 is still 0. So in one instance, x can be 2. When we are looking at this side, this factor, 3x plus 1, we want that to be 0. The only way to do that is if our x equals negative 1/3. Just to quickly show you why that is, 3x plus 1 equals 0. That's what we're looking for. Subtract 1 from each side. We have 3x equals negative 1. Divide by 3, and we're left with x equals negative 1/3. So in one case, we'd have x equaling 2 as one solution, and the other solution is where x equals negative 1/3. Those were cases where we have two roots or two solutions. There will be cases where there are only one solution. And when that happens, we call it a double solution, and I'll show you why. So these ones, when we solve by factoring, again, we want it to be an equation set equal to 0, and right now it's set equal to negative 9. So I'm going to add 9 to both sides really quick here. We have x squared minus 6x plus 9 equals 0. Now from here, now that it's set equal to 0, we can factor a lot more quickly. We're looking for the factors of 9 that are going to add up to negative 6. Now we notice that our 9 is positive, but our 6 is negative, which tells us that both these factors have to be negative. Because when we have two negatives multiplied to each other, that's where we get a positive. Two negatives added together gets this negative here. So if we know that we need two negatives, and they need to be factors of 9 that add up to 6, the only two that work are negative 3 and negative 3. So we know that we have x minus 3 as one of them, and x minus 3 as the other one, and it's still set equal to 0. Now at this point you might notice that this can also be written as x equals negative 3 squared equals 0. That's why it's just one root, because it only shows up one place here. We call it a double root because it shows up twice in this instance. Two ways to write it, both mean the same thing, but in one case we're visualizing it twice, in one just the once. If we were looking at this case, we would say that our x needs to equal 3. So we'd say one solution is x equals 3. If we were looking at our other case here, again we'd say x has to equal 3, because 3 minus 3 is 0. So our two solutions are x equals 3 and x equals 3. But if you were to ask me what my favorite soup is, I wouldn't say wild rice soup and wild rice soup. Well, you just have to say it the one time. We don't need to say it twice. It's just the one instance. So the only solution is x equals 3. Same thing over here. This one is already set equal to 0, so we're good to go there. All we have to do is find the factors of 1 that are going to add up to 2. Well, the only factors of 1 are 1 and 1, and those happen to add up to 2. So we'd say our factors are going to be x plus 1 and x plus 1. Again, still equals 0. Or we could call that x plus 1 squared. Keep that in mind. Well, I should say that equals 0. If we look at this case, our solution in this instance is x equals negative 1, because negative 1 plus 1 is going to be 0. Again, in this case, our solution is negative 1, because our negative 1 plus 1 equals 0. That way we have one or the other of our factors equaling 0. So when we multiply them, they come out to 0. Again, in this case, our solutions are x equals negative 1 and x equals negative 1. We don't have to say it 2 times. You just tell us the one time. So we would say x equals negative 1. Now, in this example, we notice that we have 2x squared minus 8x minus 42 equals 0. So you might say, oh, I want to try that new AC method that we just tried. Well, we could do that. Might take a little while. We could also notice that we could factor a 2 out of all of these terms. Here, 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 and technically even here. If we factor 2 out of that 2x squared, we're left with x squared. If we factor 2 out of the negative 8x, we're left with negative 4x. 2 out of negative 42 becomes negative 21. And 2 out of 0, so 0 divided by 2 is still just 0. So that's totally okay to have. Now that we've factored a greatest common factor of 2 out, now we can begin to factor these. In which case we're looking for the factors of 21 that add up to, or should I say negative 21, that add up to negative 4. Again, because this is negative, that means one's going to be negative, and the other's going to be positive. Because our b value is also negative, that means the larger value has to be the negative one, and our smaller value is our positive one. Well, we can probably tell from here that the factors of 21 are going to be 7 and 3. And again, 7, the larger of the two values, is the one we want negative. That way, when we take negative 7 plus a positive 3, that comes out to our negative 4. So when we write this factored, we would say that x minus 7 and x plus 3 are our factors. And again, they still equal 0. So our solutions here, in this case, we want 7, because 7 minus 7 is going to be 0. And in our second case, we want negative 3, because negative 3 plus 3 equals 0. So here is our solution set.